If you're struggling with the conservation of angular momentum for A-level PE, listen up to this. So, angular momentum is moment of inertia times angular velocity. Moment of inertia is basically the resistance to spin, and angular velocity is the rate of spin. So, if their moment of inertia is high, it means that they're very resistant to spin, and therefore they're not going to spin very quickly, so their angular velocity will be low. But let's talk about it in this scenario here, where they'd want to be spinning really quickly. So at point C here, they'd want a high angular velocity, but to do that, they'd have to lower their inertia, they'd have to lower their resistance to spin. And these are the two factors that affect inertia, the mass, but also the distribution of the mass around the axis of rotation, and you'd have to say that bit. Now, they can't alter their mass in the moment, so all they can alter is the distribution of the mass. So what they do here, they're spinning around this transverse axis of rotation, and they distribute their mass much closer to the transverse axis of rotation. That lowers their moment of inertia, which then allows their rate of spin, their angular velocity, to increase, and that's why at point C there, their inertia is at its lowest, and their angular velocity is at its highest. And then it's just the opposite for point B. So at point B, they've distributed their mass really far away from the transverse axis of rotation. That has increased their inertia, so they're more resistant to spin, and therefore they're going to spin slower, so their angular velocity will be slower at point B. And then if you're struggling with the units of measurement, because moment of inertia depends on mass, that's measured in kg, and we measure the distribution of the mass in meters squared. So you join those two things together. So moment of inertia is kg meters squared. And then angular velocity is basically how quickly something is spinning. And we measure that amount of spin in radians. And it would just be radians per second. And then because it's a times equation, you join these two things together. So angular momentum is measured in kg meters squared, radians per second.